Thanks.
Sure. So, what we'll talk about today, we'll give a brief history of the Building Safety Act and starting with Grenfell, as well as Lakanal House, Barbara Lane, and the Hackett Report. We will also um, look at the contents of the Building Safety Act, the accountable person, the building safety regulator, and the registration and acceptance certification process. We will look at the secondary legislation, which is flows from the Building Safety Act and its impact on fire, planning, structure, and the golden thread of information. The gateway processes, we'll explain what those are, and the safety cases, which is not a new concept, but it's new to high-rise construction. Um, and Brian will give us his experience of that from other industries. And we'll look at competence, which is very, very key at the moment, a big challenge for the industry. So the background of the Building Safety Act all started with the Grenfell Tower. It was a tragedy of 72 people lost their lives, and it was the one of the worst disasters for generations. It wasn't the only serious fire, and with hindsight, the warning signs were there that something serious was going to happen. Um, the Grenfell inquiry looked into all aspects associated with the building and brought in a number of technical experts, including Dr. Barbara Lane from Arup. And in parallel to that inquiry, Dame Judith Hackett was invited to lead an independent review of the entire um, building regulation system. And if you want to understand how those regulations work together, it's really worth reading her final report produced in 2018 and some of the associated materials. She goes into all the regulations and shows how they apply at different times. And it's a really high quality piece of work. Likewise, Dr. Barbara Lane looked into the aspects of including smoke control uh, in a great deal of detail, and we'll include the link with the materials so that you can read further on that. So it's important to remember that when a building is built and then, subsequent refurbishments are made, those refurbishments only need to comply with the regulations that were relevant at the time it was built, so in 1979. But those regulations didn't even contemplate, rain screen cladding and those sort of elements of the external works and a lot of the other elements of work that are carried out as well. So some of those works were not really scrutinized in the way that they should have been. And we'll talk about the golden thread later, but you can see how, the information from these various elements of work, really wasn't available to the people that need it. Um, and in 1979, the building control regulations that were available were very, very basic. Nowadays, we have approved document B, which tells us how we can comply with the regulations, and that's been updated. That was updated quite quickly after Grenfell in November 2018, and there have been subsequent updates as well, and it continues to evolve. There are alternative routes to comply, and the British Standards gives us a lot of detail about that, particularly BS 9991, which has recently been updated, and that provides some really useful guidance on the aspects of high-rise buildings, aspects such as sprinkler design and how to design open plan flats. And the guidance in itself evolves as well. So CP3 is that example there in relation to the wind loads has now been superseded by the BS 6399 series, which is now the standard that we use for calculating wind loads when we're designing the facades. So Dr. Barbara Lane looked into the smoke control in a great deal of detail. So from this isometric you can see here, so these red lines illustrate the compartments. So each apartment is an individual fire compartment, and the apartment front door, which is at 30 minutes fire resistance and self-closing, stops the fire from spreading into the protected lobby. And obviously the lifts stop working in a fire. So um, the principle that these buildings are designed to is that it the fire strategy would only ever consider that there's one flat in on fire at any one time. So the occupant would then escape in through the lobby into the protected stair. And approved document B gives us the guidance which tells us that. So Dr. Barbara Lane looked into the smoke control design. So as we say, it was designed on the basis that one apartment would be on fire at any one time. The occupants would escape via the lobby and down the stairs. Obviously, during that process, a small amount of smoke will escape into the lobby when they open the door, but that door should be self-closing and should close behind them. And likewise, when they open the stair door, that should close behind them. So this is the principle of how the smoke works. The smoke control system works. So the smoke would come out of the flat, accumulate, a relatively small amount of hot smoke. So it's going to rise, and then you would have a 1 meter square damper and a 1.5 meter shaft, either mechanical or naturally ventilated. So the hot smoke would rise up. And when the 1 meter squared head of stair vent in the stairs opens, it draws fresh air down the shaft. And when the door is opened by either the escaping occupants or the fire and rescue service, that then provides make-up air, which allows that hot smoke to escape. Unfortunately, in Grenfell, the dampers were at low level and they were much smaller than you might expect. So it didn't really facilitate the smoke control system to clear that smoke very effectively. We've also learned as well that drawing air down a building which has got a fire in it can also be challenging due to stack effect. And the design of smoke control systems is covered in a lot more detail in the EN 12101 series of standards, or if you refer to this link here, there's a more user-friendly overview provided by the IMechE. So Dame Judith Hackett's independent review covered all of the building regulations and the fire safety. She essentially concluded in her final report in 2018 called Building a Safer Future that the system was not fit for purpose, which led to the Building Safety Bill, which then, following royal assent, became the Building Safety Act. So the Building Safety Act is such a huge change from what we are doing. It is the single greatest legislative step in a generation. So in relation to construction, so all people working on high-risk buildings have to completely change the way they work. Part one is an overview. Part two creates the building safety regulator. So this is a new governing body which replaces the building control authority from the local borough council for higher risk buildings. The local borough council will still cover the lower risk buildings, but for higher risk buildings, the building safety regulator will take over, and they may appoint the local building control to do their inspections for them, but it goes through the building safety regulator. So they were part of the health and safety executive, and they're now moving across to the Ministry for Housing, Communities and Local Government, as it's now again called. It's changed its name multiple times, so you might see it called other things. Um, Building control is now it's still covered by the Building Act, but the Building Act has been varied by the Building Safety Act. And part four is really where it starts to tell you what you have to do. So it creates the concept of the accountable person, tells us how to manage building safety risk, and gives us definitions about what a building safety risk is, which is effectively something which has potential to cause the spread of fire or structural failure. And there's a process of building registration and a new process for achieving a building acceptance certificate. And it also covers remediation, and it does cover construction products, but this is not fully in action as yet. And it covers fire safety and governs the competence of architects, and there's a general provision at the end. So when we talk about a higher risk building, we're talking about a building that's over 18 meters, or at least 7 stories, and contains 2 or more flats. So that's measured from the fire service access level. So sometimes when buildings have a lower ground level or so, it can be measured from there. There's a guidance note which defines how the building is measured. And to date, there's nearly 13,000 higher risk buildings registered. And the accountable person, our principal accountable person, is the key person that the regulations point to. So one of the first jobs to do is establish who the principal accountable person is. So there can be multiple accountable persons for a given building, but there can only be one principal accountable person for any area, and that gives them the legal responsibility and accountability for reporting to the regulator and maintaining the golden thread of information. So for establishing who the principal accountable person is, it's really important to understand who has the key legal stake in the ownership of the common areas. So when we talk about common areas, obviously corridors and hallways, lobbies, reception areas, roof terraces, external landscaping. The buildings that I deal with, we have a lot of like work from home spaces, lounge areas, cinemas, gyms, yoga studios, this kind of stuff. We even have recording studios in some of our buildings now. So those are all common areas. So whoever owns those is the principal accountable person. From the Building Safety Act, if you read the Building Safety Act, if you ever want to, um, it's quite abstract in some areas because it's about setting things up and setting things in motion. But the secondary legislation is really where it tells you what you have to do. And this link here is really useful. I use it a lot to just because there's no point to downloading and saving the regulations because they're just there. So when you have to check something, this is a really important link, I think. And this takes you to the secondary legislation. So an example here is the um, Key Building Information, etc. England Regulations 2023. So basically where that comes in is once you've registered your building as the principal accountable person, for my company, that's me. I log in and register the building with my name and address and the building name and address, and the de basic details about that building, you know, how tall it is, how many flats are in it, and so on. And then I have to, once that registration's been accepted and lodged with the regulator, I have to log in again and provide the what's called the key building information. So, for example, this goes through and goes, does the building have sprinklers? Does it have AOVs? How many fire doors are there? What's the facade made of? All these things. And so for in reference to structure, for example, you describe what the main material is. So is it reinforced concrete? And what's the main principles of the design? So a lot of the buildings are an RC frame. I have a lot of modern large panel system buildings, which are um, a very modern take on a modular building, essentially. So it's two skins of concrete with a layer of mineral wool in between, and we have the windows pre-installed and the finishes pre-installed, and we bring them on a truck from Holland and we put them together like Lego, and it creates a really high quality uh, and a building with less labor on site. So I need to describe all that in the key building information, provide it to the regulator. So these are all the key bits of other of secondary legislation. There's more coming out all the time. So there's some more coming into force on the 1st of April, for example, which talks about creating person-centered fire risk assessments for people that have mobility issues, etc. So again, really key link there. One of the recommendations from the Hackett report was to uh, have a mandatory digital system of record keeping. So for companies of the size of the company I work for, keeping a digital record of our building is nothing new. So we have been doing this for years just because we build their buildings and we don't sell them, we keep them forever. So for us, for business reasons, it's the most efficient and effective way of just managing your information and keeping it in a structured way to make sure that every time you have to do something or provide information, or if someone's selling a leasehold flat or whatever, they want information, we always have it. So for us, it was just the logical thing to do, and we've had it already in place for about 20 years, but most companies actually don't. So we had a bit of an advantage in this respect, and we already complied with this legislation before it came out. But we do have to make sure that we monitor our compliance to make sure that we don't that we're following the regulations at all times. So just to give you an overview, some of the text on here might be quite small, but I've provided this more for reference. So it's just to give you an overview that it's not just about construction. So the construction of the building is this little bit here. Before construction, we have Planning Gateway 1, which is about providing a fire statement with the planning application, and that's governed by the Town and Country Planning Act and the Planning Department, and your golden thread starts there. Then when you've got your detailed design, usually a stage 4 plus, REBA stage 4 plus, where you would have your fire strategy, your qualitative design review, etc. And you would make that application to the building safety regulator. So you go onto the .gov portal, a bit like doing your tax return, and you follow the steps and upload all your information. It's meant to be done in 12 weeks. It's no secret that the regulator hasn't been able to comply with that. One of my buildings was one of the first ones to be approved, and it took 63 weeks. It's a lot less than that now, but realistically, we are planning on the basis that it's going to be 20 weeks. And a lot of lessons have been learned, and everyone's getting better at that. But all of that journey feeds into the golden thread. Then construction happens, and There's Regulation 38, which is about keeping records of the construction process. We use a piece of software called Sublono, which allows us to plan in all of the steps um, of the construction of the building and send those out to all the people that are going to be doing that for us, and they add in sub steps, and then they can then take a picture and sign off that they've done each step. So we can then go back and when the building control officer points up at the building 5 years after it's finished and says, how do you know that that fire barrier on level 12 is there? And we can look through the information and go, oh, there you go. There's a photo of that being installed and it's been signed off. So we don't have to do any of this sort of intrusive investigation in the future. It's all been documented already. And then we have Gateway 3. So this is again a hard stop. So you're not allowed to occupy the building until you go through Gateway 3. So both Gateway 2 and Gateway 3 are a complete change from the way the building control system works. In the past, I have a very good relationship with the building control officers, and we've agreed a good method of working where we break down all of the things that they want to see into conditions, and we would provide the information that he requires as the building is built, and basically he would have all of the information that he needs to sign off the building, usually the day before it's finished. Nowadays, we need to provide all of that information before we're even allowed to start, and it would be a criminal offence punishable by up to 2 years in prison and or an unlimited fine if you started without doing that first. So that's why it takes 20 weeks. And then you build the building, and then at Gateway 3, you have to go through with the regulator again and prove that you built the building that you said you were going to build, and everything is exactly documented, and any change that had to happen has gone through the proper change control process and approved by the regulator at the time, and that you've got all your commissioning information and everything safe. For example, like the sprinklers, you've tested them, you've done your flow meter tests and so on, and you know that everything works in the way that it should. But it doesn't stop there. Once you've occupied, you've got to do a fire risk assessment, usually every year, absolute minimum of every 3 years. And things get reassessed all the way through. And once it's occupied, the control changes from the building safety regulator into it'd be the fire and rescue authority, so the fire brigade basically would be the primary regulator, and they would liaise with the building safety regulator as well. And we have to provide things called building safety cases to the building safety regulator during occupation, and we will come on to that in a bit more detail. Hosting all of this information is a significant IT challenge. So there has been a standard ISO 19650 that's been around for a while, and BS 8644, which gives us some guidance on the management of fire safety information. So that these talk about naming conventions and things like that, and there are portals and systems that are designed for hosting this type of information. But there's no one system that can do it, all of it. Like I said, we used a system called Sublono for keeping our site records. So during the early stages of the design, we would have a building information model, and we would have drawings and technical submissions. And we also use a thing called an external wall matrix, which basically is a big matrix that just checks that we've got everything that we need to have. And then we use a system called Fire DNA for monitoring our fire doors, because once they're designed and they're compliant, we have to check them quarterly. That's one of the pieces of the secondary legislation that means we have to check those fire doors every 3 months to make sure that they remain compliant and they close in the way that they should automatically, as we saw in Barbara Lane's report there. So we use a system called Fire DNA, which works on QR codes, so you can scan it with your phone and it'll tell you when it was last checked, what the performance is, and if there's any problems with it. So that forms part of the golden thread, and that talks to our central system. We also have a fire risk management system which gives us live data on things like, the sprinklers, are they working? Have they been maintained within their, has their annual inspection been done and do they work properly? Has the wet riser been tested in accordance with the standard, and so on. And some of these things, for example, within that, there's even daily actions. You have to check your fire alarm panel every day. So we would have records in there that of us checking the fire alarm every day and checking the escape rooms to make sure they're clear, no one's left any rubbish there or whatever. We have to check all that every day, and those photographic records go in there and get managed in this fire risk management system. And then say, for example, we checked our fire alarm and there was a problem with it, and we need to get the contractor to come and fix it. We send that automatically to a CAFM system, so a computer-aided facilities management system. So all of the contractors that we've appointed who are qualified to work on sprinklers or fire alarms and so on will be in there. And we can send them an alert and say, oh, there's a problem with the fire alarm panel. We need you to come and have a look at it. We'll grade it with a priority. So if it's a priority 1, they'll come out immediately, absolute maximum within 2 hours. And they'll come out, investigate, and resolve the issue. If it's a lower priority, they might come out the next day or whatever. And once they've done that, that creates a record, and they close it out, and that gets recorded in our risk management system, and our risk will go down again. And obviously, we have to work safely, so we have methods statements and risk assessments for all of our works, and we assess the competence of our contractors, and we tender them to make sure that we're getting fair value. And the records of all of that goes into the golden thread as well. We can then take information out of the golden thread to register our buildings with the London Fire Brigade and provide them with information. So if there's an incident, in the back of the fire engine, when they're attending that incident, they have a tablet and they can open up the information we've provided and they can have a look and find out about the building that they're arriving to before they get there. The only challenge with that is in central London, you know, the attendance period is usually around 3 to 4 minutes, so they don't get much time to look at that information by the time we arrive. So we have hard copies of that as well, and we present it to them when they arrive. We keep that in a premises information box that looks like that. The high-rise building registration process requires us to export information from the golden thread. And if we have to do any subsequent works, for example, there's a shop on the ground floor, it's changed owners, they need to do some work and refit it into, an art gallery or whatever, then they take the information from the golden thread. And we use that information also to do a thing called a mandatory occurrence report. So if we discover something which has potential to contribute to the spread of fire that could affect multiple people, then we have to fill out a thing called a mandatory occurrence report, and we need information from the golden thread to report that to the regulator. And we need to have a system for managing complaints as well. If a resident complains about something, we will have a look at the golden thread, and we have to keep records of that complaint, make sure it's dealt with. And part of the secondary legislation as well is also to have a resident engagement strategy. So a way of meeting and discussing matters with the residents and providing with the information about their building and what to do in the case of fire. But if you were provided information that was just about what to do in case of fire, a lot of people wouldn't pay attention. So what we do is we have an app that provides them with all sorts of other information, like offers in the bars and restaurants elsewhere in the development. Also, they can book gym sessions, yoga sessions. They can get the valet to bring their car down, things like that. So they're using that app all the time. So it's a really good way of providing them with information, reminders. So, for example, there might be a festival coming up and say, okay, as a reminder, during the festival, don't leave candles unattended, don't use fireworks, don't have barbecue on your balcony, things like that, just as timely reminders to help keep yourself and your neighbours safe. So the implementation of this golden thread, like I said, I was very lucky that most of our buildings have it already. But sometimes as a principal accountable person, you might have just bought a building that was built by someone else. So you need to then build that golden thread, and that can be really challenging. Some buildings have no information at all. So what I do is I make up a little schedule that has like the basic minimum. So this schedule here is what I use as my like checklist. So if I haven't got all of these things, then there's a real problem. So I would look for a fire risk assessment, type 3 fire risk assessment. I'd look for a structural risk assessment and look for fire strategy reports. If I don't have those things, then I'm going to have to get them. So I would commission a structural risk assessment if there isn't one, for example. If there isn't information about the fire separating elements, like we spoke about earlier, we design flats on the basis of it being a safe compartment. So you're safe in your apartment for usually at least 30 minutes, usually 60, um, as long as you're not affected by fire and smoke. So you don't have everyone trying to evacuate at the same time and clogging up the communal areas, potentially exposing themselves to smoke and other injuries. But none of that works if the fire separating elements are not robust. So we have to have information about that. And if we don't, we need to go and get it. So that's what I do is I typically work through this and make sure that I've got all of these things. Zoning drawings, for example, if the fire alarm goes off, the zoning drawing will tell me where in the building that fire alarm has gone off. If I don't have that zoning drawing, fire alarm is mostly useless. So it's absolutely essential to have this information. So the Building Safety Act, um, when it came in 2022, its idea, the idea was to um, completely change the way we think about um, higher risk buildings. So, like I said, we have Gateway 1 is about planning and the design of the building at planning. Gateway 2 is this process that's very detailed and goes through the building control process. And this is the big challenge that all builders are going through at the moment. And Gateway 3 is making sure that the buildings are ready for occupation. So not many buildings have gone through Gateway 3, and that is going to be just as big a challenge as Gateway 2, but the reason we haven't heard about it is because we haven't got there yet, basically. So one of the reasons that Gateway 2 is such a problem is that, builders are just not ready to provide information in the way that it's produced, and the regulator, frankly, is not ready to read the information in the way it's produced. So there's a lot of learning on both sides. So the Construction Leadership Council has tried to bring that together by providing guidance to the industry. So there's some really good work here. There's a link available at the top there. So we talked about building assessment certificate earlier. So you might see these. They have to be provided in a prominent place in the building. Now, not many buildings have them. Last time I checked, it was around 15, but that was a little while ago, so it's probably a bit more now. But you will see these appearing probably on the ground floor in the common areas of higher risk buildings. So basically, if you've got a building assessment certificate, that means that a safety case report has been provided by the principal accountable person. They've got a system of mandatory occurrence reporting. They've got a system demonstrating compliance, and they have a resident engagement strategy. So the safety case is the biggest ingredient. That basically is a case that puts together the argument that says that this building is safe because, and it goes and it works like that. So it's a little bit like a thesis. You know, the ones that I write, they're typically around 60 to 70 pages, and there are appendices of around 22 documents, 22 to 26 documents as appendices. It's a substantial piece of work, and they have to provide reasoned arguments and it's not just dumping ground for all of the information that you have. You have to get involved with your building and really understand it, and then justify to the regulator that it's safe. So it goes through a process of identifying all known risks and what are your mitigations for those risks. So there are different methods of doing that. I use a method called the bow tie analysis, which identifies the risks and the mitigations, and how do we manage those. But the management process is if a risk has to be managed, the management is usually the weakest form of risk control, because if you're relying on management, you're relying on people, and people go sick, they change jobs, they get bored, they don't pay attention, things. So it can ha it can things can fall down. So engineering controls are always the most preferred method. So you engineer out the risk so it's eliminated. And only if that's impossible or not feasible or not cost effective, then we would look at the other options via the principles of prevention. So uh, to try to put some manners on the process, the Building Safety Act only considers risks of fire and structural failure. We obviously other aspects like Legionella, for example, they're covered on under the buildings the Health and Safety at Work Act. So obviously, that's Legionella is obviously about water safety, and there are other regulations that cover the other things. The Building Safety Act doesn't cover everything, but it does give us a way of managing uh, our process. So, for example, in the company that I work with, the risks of Legionella, we manage in the same way as we would manage a building safety risk, but just because it's a good way of managing risk. So we assess risks via different methods. So, for example, we would, on a typical year, we would do a water risk assessment, um, a structural risk assessment, a fire risk assessment, and every 5 years we would do a external wall fire risk assessment as well, and a general health and safety risk assessment. And we would do targeted risk assessments for other things as well, such as because we have quite extensive leisure areas with multiple swimming pools and spas and gyms and yoga studios and so on, we do a separate risk assessments just for those, um, and playground risk assessment as well. So all those risks identified in that process go through a risk management process, and there's a link here that provides a bit more information about that. But if we don't have compartmentation, then a lot of our controls fall down. The uh, compartment flats are basically designed on the basis that we have reliable compartmentation. So that means that the fire can't spread from one compartment to another within a prescribed period of time, which gives enough time for the occupants to escape. So the risk assessment process goes through a system of identifying hazards, um, and compartmentation is one of those key things. So a compartment wall, for example, would be a plasterboard wall typically. And then we have fire stopping, which is where some penetration has been made for pipe work or whatever. And the fire stopping is usually a mineral wool bat, which is friction fitted in the space. So it's dense mineral wool and it gets compacted into the space, and it has an ablative coating which reacts and expands and fills any gaps when it gets hot. So if those systems are not in place, smoke and fire can spread between compartments. If, say, for example, those fire doors are not up to standard, then the compartment line is broken and the risk increases, or if the doors don't close, then you don't have a compartment at all. So that's why there's so much emphasis in the secondary legislation about automatic door closers. And again, the smoke control system is fundamental to that as well. I'm just going to bring Brian in here because he's a real expert in this area. So he can give you a bit of information about the history of the safety cases.
Okay, I hope you can hear me okay. So, as Ben said earlier, safety cases have been around for some time and have been extensively used in other industries, but are something new to the construction industry, or at least the construction of residential premises, certainly. And I just put here a sort of brief history of safety cases. The first big major incident, which was followed by the introduction of safety cases, was a significant release of radiation at Windscale nuclear reactor in 1957. And as a result of that, the Nuclear Installation Act includes the production of safety cases, just like Ben described his 60-page document. I think the nuclear safety cases are really huge documents sometimes. And then in 1974, the Health and Safety Act was introduced, which is a kind of very general act covering the issue of safety in the workplace. It was the result of a commission chaired by Lord Robins. And that introduced the idea of a duty holder. In other words, somebody who was responsible for that piece of equipment or that building or that installation, somebody who had responsibility for making sure it was safe. And then the offshore oil and gas industry had a very terrible accident in the Piper Alpha oil rig. You may remember that in 1988. And so safety cases were introduced in the offshore installation regulations for the same reasons. You clicked on Ben. Next slide. So here's a couple of pictures. Sorry, go back one. So there's a couple of pictures. There's Windscale reactor. That's up in Seascale. And then the Piper Alpha oil rig was in the North Sea. So you can see that in the case of Windscale, that's where they've accidentally released radioactive material into the atmosphere. And obviously, besides being very dangerous for the people in the plant, that really affects a lot of people outside the plant. The Piper Alpha oil rig really only affected directly the people who were working on the oil rig because it's in the middle of the North Sea and not many people nearby. So we go to the next slide, please. So here's three more disasters. Flexborough is a chemical disaster in 1974, and there was also, not long after, was a huge disaster at Seveso in Italy near Milan. And in both those cases, huge clouds of very dangerous chemical smoke were released, again affecting nearby residents as well as the workers in the factory. And then in 1999, there was Ladbroke Grove rail crash, was perhaps one of the worst rail crashes. And here we see the first example really in this series of passengers being affected. So obviously, if you have a rail crash or an air crash, we have a lot of passengers involved and potentially very high number of people could be killed directly. It doesn't so much affect people outside the situation, but this is a lot of people in the situation. And then Grenfell Tower is, as we said at the beginning, one of the worst fires in a residential building. There have been some equally bad ones abroad, but in the UK, it's probably the worst one. And again, we've got large numbers of people in these buildings, but in this case, they also affect the people outside the building to quite a large extent. Next slide, please. So there's the chemical control of industrial major accident hazards called CMAR, was introduced in 1994. That was actually brought in as a result of European community regulation. The railways introduced safety cases in 1994, and then the first of all, the civilian one in 2010, and the military one followed shortly afterwards. And then we had the Building Safety Act in 2022. And there's quite a good write-up of the history of safety cases by Mr. Ing, which you can find online very easily. Next, please. So one of the things about building safety risks, which we have to look at in arriving at a safety case, is how far do we have to go? And in the Building Safety Act, it says we have to take all reasonable steps. So that means we have to take all reasonable steps to try and prevent one of these big calamities happening. And also we have to take all reasonable steps to try and reduce the severity of such an incident if it does happen. So the first one is trying to prevent anything happening. The second is trying to reduce the effect of this happening to its minimum. So why do we need a safety case? Well, I think there's two real reasons. The first is these big disasters are fortunately very uncommon. We don't see many of them. That means that there's no statistics about them, and we almost have no way of forecasting them. So the only thing we can do is to look at all the risks and try and make sure we've covered everything we can and taken all reasonable steps. And equally with minimizing, we have to imagine if something nasty happened, what could happen and how would we take care of that? So most big accidents actually involve a series of incidents when you look into the examination. So for example, in a building, usually this is a fire in a flat. It might be due to a badly maintained appliance, an old fridge or an old washing machine. Or recently, a lot of fires have started where people have been recharging electric bike batteries, and the bike battery has gone up in flames, and these things are a really bad source of fire. And then the second part of the sequence is the fire escapes from the building, from the original compartment that it's in. And quite often this has been through the window, because the window is often the weakest point in some of these buildings. It may be old windows. It may well be that the windows have been left open by the residents, so the fire can go out quite easily. And then the fire needs to find additional fuel. So in the case of Grenfell, that was the cladding. It found the cladding and found this was a nice source of fire fuel. In the case of Lakanal House, it was the panels under the windows and also the other bits of the building which turned out to be inflammable, and these made the spread of fire to other flats very easy. So you have to remember that in a building site, normally the fire engines only arrive after a few minutes, and that first few minutes is very critical. So when we think about putting forward a safety case, we have to think about, are we doing enough to protect people during that first few minutes? In aircraft, they've taken a different approach, really, because their risks are different. So, for example, they might consider, what do we do if there's a fire in the aircraft when it's up flying along? Or we might have another risk, which is, for some reason, we're coming into land and there's something on the runway. What do we do? So they've got all these different sorts of risks. Equally, the railways have different sorts of risks. So, for example, the signalling system might have failed, something wrong. It says to the rail, okay, the railway is clear for you to go ahead, but it's also said the same thing to a railway engine come in the opposite direction. So that was the cause of some of these accidents. So safety cases really are here to stay, I think, and they, as Ben said, this is challenging people in the industry quite considerably. When we come to competence, Dame Judith Hackett really focused in on competence and said this was something that really had to be dramatically changed in the industry. And for professional engineers, such as yourselves will be, the Engineering Council has developed the UK Spec HRB qualification for people working on high risk buildings. So that would be a qualification which we hope will become routine and everyday thing in the industry in due course. And the British Standards have issued a British Standard series actually under the number 8670. It's also 8671 and 8672 and 8673, which tell you what are the competencies you need to work on these highly risk buildings in a safe way. Thanks. Next slide. So the Industry Competence Committee, which is one of the committees set up under the Building Safety Act, have realised that this is quite challenging for a lot of people, and they've put out a series of competence principles. So I'm not going to go all through these, but this is essentially is a plan to both to see whether your current employees are competent, or a contractor you want to employ is competent, and how do you keep on checking that the competence is maintained, and how do you manage things like information and change related to competence. So, for example, if a new competence level is required for certain things, have you built that into your system? Okay, next slide, please. So last but not least, I think what we have to suggest is you need to keep a lookout for new information coming. A very good source of information in construction is the Cross website. I think you may already know about this. And this is a kind of voluntary reporting site where people from both the Institute of Civil Engineers and the Institute of Structural Engineers volunteer reports on incidents and unsafe working practices and so on that they've come across. So, for example, this particular one is about corrosion on the outside of a building, which is in a marine environment. And you can see that some of the renders come off, exposing a reinforcing mesh. And this becomes a very unsafe situation. So go and have a look at Cross. They have lots and lots of incident reports. Very interesting site to look at. Next slide, please. So here's some challenging problems for you to wonder what happened here. On the left-hand side, Ronan Point. So you can see that the whole corner of the building failed. But how did this happen? So this was a gas explosion in one flat, and that caused this building to collapse along the corner. This is what's called a large panel system. And rather as Ben described for his buildings, these were factory-built panels put together rather like a Meccano set or a Lego set to build a building in around 1970, I think. So there are still a lot of these buildings about. And after the incident, the analysis was that the pressure of the gas explosion could not be contained by this design of building. And various recommendations were made to make sure that any building still of this type should be either improved structurally or demolished, or whichever was the correct thing to do. Now, the one below Miami seafront apartments is relatively recent. You can see a whole block really has collapsed there. And that goes back to the Cross report that I just mentioned. They think that the reason this collapsed, this was a seafront apartment. They think that due to the sea air around these buildings the whole time, spalling occurred at the bottom of this building. So some of the concrete fell off, exposing the reinforcing, and that over a period of time was corroded, and eventually one day, bang, the whole lot came down. And then another American one, the Bronx apartment, was very recently happened. You can see again a whole section of the building has come down. And this one occurred because of a fire or explosion in the heating system, which was at the bottom of the building. And this took out this whole section. So in each of these cases, there are challenging structural things to think about. The last one there is an internal crack in a building in London. And this is a bit different because this is not necessarily a terminal crack. It may be that this crack is stable, but it does involve people such as yourselves perhaps in the future in monitoring a crack like this. You may have to put some special equipment on it to monitor its growth and finding out why has this crack occurred. It could be due to subsidence below the building. It could be due to heavy road usage by large trucks coming past the building. But you have to check on it and see whether it's safe. Now, when you come to submit your safety case, this is putting people in quite difficult positions because they have to say to the building regulator, okay, I've done this building, I've done all my work, I've assessed all the risks, I've mitigated everything I can, it all looks good, except we have this crack in the basement. And I'm still working on this crack. How do I get an assessment or a certificate for this building? And then that becomes a tricky discussion with the building regulator. So that's one to think about. Okay, I'm sure Ben has some experience of this